So this is where how do we study in this class. Now you can, if you are if you are trying to participate in math cons or MC8, then this should be the good class for you to improve your mathematics. Okay. Our first problem I want to discuss is today we're going to focus on algebra. Okay, so every time what I'm going to do is every time I focus on one topic, maybe plus a couple of problems from students. Hey, I have a homework problem, and you need to discuss. Sometimes I delay it for a while. Sometimes I put together. Okay, sometimes I just add a couple of problems which does not belong to the topic. Okay, that's fine. So today I'm going to begin with the algebra, and let's look at the first problem. And I will also ask you to think about, and sometimes I ask you to explain how to solve the problem. Okay, if you get some ideas. Okay, so we have. Let me try. Yeah, let's begin with a simple one. This is from math cons, but it's pretty simple. But let's begin the first problem. So what is quotient when when the first 6x to the power 2a plus b minus c divided by 3x a plus 2b plus 3c. Okay, yeah, just simplify this expression. I just want to make sure you know how to do this type of problems. Okay. Well, you just needed to use a very basic formula. Okay. The formula you're going to use is going to be if x is to the a and divided by x to the b, and that's just x to the a minus b. Okay. And the same also is going to be if you put it in the denominator, it will be 1 over x to the b minus a. It depends, sometimes it's required to get a positive power, then something you have to put in denominator, right? So this is a basic formula we're going to use. And using that formula, the above the expression, is going to be a plus 2b plus 3c is going to be 6 over 3 is 2. Then the difference of those two powers. Okay, so let's simplify it further. So you have a 2a minus a is just a. B minus 2b is minus b. Negative c minus 3c is negative 4c. Okay, so that's it. Now, if you want to, you can also express in a slightly different way if we want to put the x in the denominator. But right now we don't know a minus b minus 4c is positive power or negative power, we don't know. So we just leave it like that. Okay. So the second problem, we assume that, c plus d equals 3, d plus e equals 4, and the c plus e equals 8. We want to find the value of a times c times d times e. Yeah. Okay. The express answer to nearest, just express answer as a fraction. Okay. So given this type of problems, what is a quick way to do? So think about this, okay? And if you get answers, you type the answer in the chat window, and sometimes I will ask you to show me the best idea. Okay, if you did it quickly, I want to know why you did it so quick. Okay, maybe you can share the ideas with other students. Okay. Yeah, actually, there are many ways to solve this problem. But what is the best quick way to get an answer for the value of c times d times e? It seems to me we have to find the individual values of each variable, right? You have 3 variables, 3 equations. So you should be able to get, you should be able to solve this system of what we call linear equations, right? Grant, are you working on the problem? Okay, good. So if I ask you to show your ideas, you have to turn on the microphone so everybody can hear you. A problem like that, normally you are given, I believe that you're given 45 seconds. There are 2 types of problems. So one type of problem you are given 3 minutes, and no, not 45. Okay. Other type of problems, I forgot. Yeah, this is 45 seconds means for the countdown problems. Yeah. Okay. So look at those 3 equations. They are very symmetric in the sense, in the same format, just c plus d, d plus e, c plus e. So in that case, you need to add the 3 equations together to get a plus b plus c plus b plus e. Okay, so you add them together, you get 3 plus 4, right? 3 plus 4 3 plus 4 plus 8, so you will get 15. Then you get a double c double d double e, so c plus d plus e is going to be 15 over 2. Okay, so once you get that, then you can use subtraction to get the answer. Okay, you get subtraction. So for example, c is going to be c plus d plus e minus d plus e. So 15 over 2 minus, c d plus e, 15 minus 4 is 4. And then you can simplify, and this will be 7 over 2. Okay? Yeah, 7 over 2. Okay? And the d is going to be c plus d plus e minus c plus e, right? Then you get a d. So 15 over 2 minus 8. And that will be negative 1/2. So you can quickly get the answer, right? E is going to be c plus d plus e minus c plus d. Okay, so 15 over 2 minus 3, so it's 9 over 2. Then you get all the solutions. So the reason, this is the best way to do. I believe that because for this special equation, linear equations, okay? So then c plus d times e is just product of those numbers. 7 over 2, negative 1 over 2, and 9 over 2 after simplifying, right? And 7 times 9 is 63, and the bottom part is 8 because 2 times 2 times 8 is 8. So 63 over 8. Now, Erica probably made a computation mistakes. Yeah, so get negative 7, right? And but if you for general system linear equations, this is not the there are different equations have different tricks to solve quickly. But the standard way is to use a substitution. The standard way use a substitution. and I'm going to show you the standard way. Okay. Yeah. Use a substitution. So your method is correct. That's a very general method. Okay. And so you can solve the systematic linear questions. For example, let's really try this general standard method. Okay. So C, so we have C plus D equals 3, D plus E equals 4, C plus E equals, equals 8. It's equation 1, equation 2, equation 3. Okay. So there are many ways to do, and use substitution, use subtraction, and I can show. So there are two different methods called substitution. Subtraction. So subtraction, you can see that, right? Equation 3 minus equation 2. What do you get, right? Equation 3 minus 2c minus d equals 8 minus 4. It's a 4. So once you have this, it's called equation 5, right? Then equation 1 plus equation 4. Yeah, this is equation 4. Equation 4. Then you have a double c, and then 3 plus 4 is 7. And then you can also quickly get c. Okay, 7 over 2. Now once you get c, you can get a e, and once you get e, you can get a d, right? Once you get d, no, so then you use this first equation again. D is 3 minus c, so 3 minus 7 over 2, okay? And negative 1/2. Then you can use any of the above equation, like equation 2, right? And then by equation 2, E is again 4 minus D, 4 minus negative 1/2, 4 plus 1/2, right? So 9 over 2. So you will get all the three solutions. That's a standard way, but you have to be very careful. Okay? I think this is a it's a mixture, I would call it elimination method. Yeah, elimination method. Let a couple equations together, eliminate some variables. Right, this is called system of linear equations, and our next problem I want to discuss. I always give you time to think about. Okay, what part of this is a trivial problem. Okay, what part of 1/2 of a square meter is half meter, 1/2 meter squared. Okay. Okay, let's understand this question. 1/2 of a square meter is half meter squared. Okay. Okay, you need to just understand the sentence. Okay. So what part means you compare the two numbers. Okay. What part of 1/2 of a square meter? Half of a square meter is half meter squared. Right? So that means you have to compute those two numbers. Okay. So 1/2 of square meter is half, 1/2. Half squared is a quarter. Okay. So no, opposite way. Okay. Half meter squared. Half meter squared is going to be a quarter. Half meter squared, right? Is 1/2 squared, right? This is 1/2 squared. Then half of a square meter, right? Half of a square meter is going to be 1/2, right? So the ratio gives this answer. The ratio is going to be, okay, what part of 1/2? So it's 1/2 is, yeah, we should consider this ratio, right? It's going to be 1/2 meter squared. So 1/2 meter squared should be the result, which is on the top. And the answer is going to be 1/2. Okay, what do you got, Grant? You got the 1 square root of 1/2, 2/2. Yeah, that's right. You know, just awkward, but they understand the sentence, okay? And that's just, the problem itself is not complicated. Just understand the question. Yeah, Erica did it the opposite way. Yeah. See, you know, in general like that, right? Okay. In general is if A over B equals C, okay? If A over B equals C, that means, okay, then we say that, well, C over B is something like that equals A, right? Right? If suppose it's going to be 1/2, yeah, what part? So this is let me put a percentage here. Usually when we say something, it will be like a, yeah, if we put a percentage, it's going to be R%, okay? Then we will say that R% of B is going to be A, okay? Sometimes we usually do that. That's right. R% of B is going to be A. Now, if we don't use a percentage, then A over B is going to be, after simplifying, suppose it's going to be like a 1/2 or yeah, or 2/3. Yeah, let's say use MN, right? Then we say that MN of B is A. Okay? Right? Clear? Yeah. If M over N is 1/2, then 1/2 of B is going to be A. Yeah. Okay, great. Our next problem is trying to yeah, that's right. What part of a half is a fourth? That's true. You're right. All right, so our next problem is going to be how many ordered integers A, B, C have the property that each number is a product of other two. Okay, so we are going to find out how many ordered integers. Yeah, integral. Okay, integral tuples denoted by ABC. Okay, and have the property that each number is going to be product as a two. Okay, so so that means you are going to get those three questions. Okay, so I want you to solve the three questions to try to find all the solutions. That's it, right? Trying to find all the solutions. Those are not linear equations. Those are not linear equations, but they're similar one to the problems we solve. It's the equations are in similar format. Instead of a product addition, that's a product. B times C. Right? So I'll let you to try. I hope you find all the possible solutions. Okay, please. I hope someone can give me a right answer, okay? See, if you see a questions in the similar format, then maybe you're just trying to find the value for some quantity first, and then use that to define the individual values. The grant says only have two solutions. I think it's more than two solutions. You missed some. Okay. Okay, then do. Pretty close. You missed some solutions. Okay. Yeah, Grant. Yeah. So Grant, did you find the value of a times b times c first, or a squared b squared c squared first?
Well, first I just solve like, so c squared equals 1, and like, for example.
Oh, okay. Then because a squared equals 1, c squared equals 1, then a b, c so plus minus 1, right? Then
yeah.
you exclude some cases. That's correct. Now under the assumption c squared a squared equals 1 is under assumption a, b, c are not equal to 0. So probably Kevin missed the one solution 0, 0, 0. Yeah, I guess so. Because otherwise he got 4 solutions. Okay. Okay. So now yeah, we can find for example, there are a couple ways to do, right? We can find the a times b times c first. We can also find yeah, there's a couple ways to do. Okay, so we can try just like a a equals b times c, but we also know that c is going to be yeah, c is going to be yeah, c, where's the c is going to be ab, right? So you get a square b, for example. Okay, right? Then from here well, no, this is not the way we do. Okay. So A is a B times C, and C is going to be, yeah, let me try different. It's not. Okay. Yeah, so let's use let's replace B. B is A n times C. So you have a C, okay? So you got AC squared, okay? And from here, you have to assume that if A is not going to be 0, then C squared equals 1, okay? If A is 0, then B is 0, C is 0, okay? So similarly, B equals A times C, and then you can, I'm going to get A squared, right? So C is going to be replaced by, yeah, C is going to be replaced by A times B. So you get A squared B, okay? And then C is going to be an AB, so I needed to get B squared. So I replace A by B, C, then C here, right? So then you get BC squared. Now, the first case, you assume that, well, you want to look at the first equation. So you assume that A is 0, because A could be 0. If A is 0, then you will see that this implies B is 0, C is 0 from the from the second and third equation. Okay, because C is A times C. B is A times C, C is A times B. Then the case 2 is A is not going to be 0. If A is not equal to 0, then the first equation we got, that's the second equation, that's the third equation. Then by the first equation, right, C squared equals 1. And then, since A is not going to be 0, right? And if A is not going to be 0, B is not going to be 0, okay? Because A is going to be times C. So then by the second equation, you will get A squared equals 1. And then also, this is by the second equation. By the third equation, you get C, we got C squared again. I actually need a A squared, B squared, okay? So I think, yeah, let me see, B squared. I need to replace AB, A times B, right? A times, yeah, C is A times B. I needed to replace A, so I get B. Yeah, this is a B, so it's B squared. That's a mistake, yeah. So then it's B squared equals 1. So you have so basically you have A equals plus minus 1, B equals plus minus 1, C equals plus minus 1, and then you double check which one works, okay? Right? And then you will quickly get few solutions, okay? And you can say A equals 1, then and you have you have a 1, 1, 1, 1, negative 1, negative 1, right? Then you have a negative 1, 1, negative 1, and the negative 1, negative 1, positive 1. So those are the 4 solutions. Total, you get 5 solutions, okay? So total, you get 5 solutions. You can also try to plot, because you see, if A equals BC, B equals AC, C equals AB. So when you look at those equations in similar format, okay, yeah. Okay, then you write down, you multiply them out. So you get A, B, C, then you have a BC, AC, AB. Okay, so what you got here is, yeah, when you have a 3 similar equation, we don't use a substitution yet. That's a middle step usually. You find the ABC, right? So you will get ABC squared, right? Yeah, you get ABC squared. So you have a ABC equals ABC squared. So you have 2 cases. The first case is if ABC is not going to be 0, then A times B times C must be equal to 1, right? Because it looks like that, x equals x squared. How do you solve an equation like that, right? then you divide by x, assuming x is not 0. If x is 0, both these are equal, right? Then from here, you can get the value, because the product is already given, okay? Then you also get, a squared equals 1, b squared equals 1, because a equals bc. And you multiply both sides, and the a squared equals abc, so it's 1, right? That should be, yeah, it's a similar way, right? And the b equals ac, that implies b squared equals abc, that's also 1. And the c equals ab, that implies c squared equals abc equals 1. So then you have a multiple solutions. Okay. The second one is if a, b, c equals 0, and then one of them is 0, but one of them is immediately you can quickly see that a equals b equals c equals 0. Okay. As long as one of them is 0, then you can go back to the equation. You can look at. So there are slight different approaches here. Yeah, they are all should be different. Okay. So we get 4 different solutions plus 1 trivial solution, total 5 solutions. Right. So this problem belongs to this algebra problem, just solving equations, but the equations are in similar format, just like the 3 equations we saw first. Okay. Our next problem is there's a so-called golden mean. The golden mean is denoted by G, is a positive number, okay, that is 1 more than its reciprocal. Okay, let's find the value of G. Okay, try this. Solving equations. Single equation. Based on the given information, you get one single equation. What is the reciprocal? We put a number, yes. Yeah. For example, the reciprocal of 4 is 1 over 4. Ketan is asking, is G a whole number or a fraction? Well, a number, okay, in mathematics, a number can be anything. Can be a real number, can be complex number, okay? But we're not again talking about complex number, so usually it's a real number. The real number consists of, the real number could be rational number or could be irrational number. Right? It's not necessary to be integer. Only for a student in the elementary school that our number is always means 1, 2, 3, 4. Okay? That's a whole number, right? So the set of all rational numbers are countable. That's a different story. And irrational numbers are not countable. You cannot count 1 to 1, one by one. There's just infinite many, too many. The set of all rational numbers also have infinite many numbers, but you can count. And we call the countable number not countable. Okay, so Richard, what is your method to find this solution? Yeah, okay. So G is going to be one more than its reciprocal, okay? This is the first equation you should write down. Then you simplify this equation by multiply both sides by G, so G squared and G plus 1, right? You multiply it by G, both sides. Then you get a quadratic equation. Now, quadratic equation, if it has integer roots, then you can usually can factor it and can solve it. But sometimes you cannot factor the quadratic function. So you have to use a quadratic formula. Okay? Right? Then you have to use the quadratic formula. So quadratic formula tells you it's a negative b, so it's a negative b plus minus b squared minus 4ac, right? Then after you simplify, it's 1 plus minus square root of 5 over 2. But one number is small, negative, other one number positive. So the answer was 1 plus square root of 5 over 2. This is a positive number. Right? So here's the formula, right? ax squared plus bx plus c equals 0, right? The solution will be this that's a quadratic formula. Okay? So you in general have two solutions. This so-called quadratic formula always give a solution. But not always get the real numbers. Okay? So for example, if I try to solve this equation, what do I get? X is going to be 2 times 1 is 2, negative 1 plus minus 1 squared minus 4ac. So I get negative 1 plus square root of negative 3. Now the question is, how do you define square root of negative 3? Okay, square root of negative 3, formally you can write square root of 3 times negative 1. And it can be square root of 3 times square root of negative 1. So the question is, how do you define square root of negative 1? Okay, so square root of negative 1 is not a real number. Okay, real number consists of a rational number, irrational numbers. That's not a real number. So you can say no real solution. Okay, so no real solutions to that equations. Okay, but if you really want to go beyond your imagination, okay, you can say this is a solution. Okay, we can denote negative square root of negative 1 by I. I means the initial of imaginary. Okay, initial imaginary. Then square root of negative 3 can written as square root of 3i, and then x, the solution, can be expressed as negative 1 plus minus square root of 3i divided by 2. So those are called complex numbers. Okay? The complex numbers. Okay. So now you already learned complex numbers, right? So yes, in the complex world, not the real world, there are two solutions. Okay, and those are the imaginary. I is the imaginary number. I has some properties. I square is going to be negative 1. Coming back to the real world, if you square it, you get negative 1. Okay, but I itself is going to be imaginary number. So I cube is going to be I squared times I. I squared is going to be negative 1, so it's negative I. Okay, so you can do lots of computation, just assume I squared is equal to negative 1. Okay, so you can say product of two numbers is going to be, it's going to be the product of two numbers is going to, I squared is going to be negative 1. Okay. So this is about a little bit about information about complex numbers. It's a wonderful. Okay? Okay. So our next problem. Solve this equation, 222 to the power x minus 111 to the power x is going to be 7 times 111 to the power x. Okay, then you solve for, of course, solve for x. Okay, please work on this problem. Okay, if you get answers, just show to me. Okay. So how about the other students? We have several, okay, a couple of new students here this time. Lee, right? Riley, do you have answers?
Not yet. Still solving.
Yeah, of course you have to simplify this equation. The key point is, you have to simplify this equation, right? You cannot work on this very large number, 222. And right. So look at the right, 222, 111. What's the difference between them? 202 is going to be 2 times 111. Okay, right? That's the key step. So then you get 2 to the power x, 111 to the power x, minus 100 to 11, and 7 times 100 to 11. Okay, so this is a common factor. It should be gone. Okay, you divide this should be gone, right? Or you can write again, take this out, right? So this can be gone. Then the equation becomes very simple, right? Right? It's 2 to the x is going to be 8. Right? 2 to the x equals 8, then clearly x should be equal to 3. Right? Richard says no solution. No, there's a solution. Right? X must be 3 because 2 cubed is going to be 8. Right? 2 cubed is going to be 8. That's good. Okay. Yeah. You just find a way to simplify it. Okay. The only key step is 222 is going to be 2 times 111. Right, those are the challenging problems, right? Sometimes when I expect it seems easy, now you probably stuck with somewhere. So I did not get the answer quickly. Erica this time gave me the answer quickly. Great. Right. Our next problem is trying to solve this equation, square of x greater than x. Right. We're improve our algebraic knowledge using these examples. Okay, I cannot teach you all the rules we should learn. I'll use examples. I will show you. Yeah. Okay. So this is a simple equation. Please go ahead and solve it. This is inequality, not equation. Honestly, all the problems we're discussing here, if you ask the elementary school math teachers, they're not able to solve all of them. Okay, this is the current situation here in public school. So, yeah, but those are the problems I collected. If I taught to this class many times before and using the math counts problems, but usually more than 2 students miss the problem, I just collected them and so I can discuss in the future classes. Jared asking, you do not assume x is fractional, right? We just solve it, see what we get, right? Couple students gave me the answers already. All right, so let's go over some formulas in inequalities. Okay, inequality, be very careful. If a is greater than b, now when you square it, when it's going to be a the question is a squared greater than b squared? Okay. Oh, dear. There should be an infinite solution, but you have to describe in the inequalities. Okay. So a greater than b does not imply a squared greater than b squared. Okay, I'll give you an example. 3 greater than -2, -4, right? But then this is not going to imply 3 squared is greater than -4 squared. Actually, it's the opposite way. Because this side is 9 and that side is 16. So 9 is not going to be greater than 16. Right? So you have to be very careful when you square it. Okay? And then conversely, a squared greater than b squared is not going to be a squared greater than b squared, does not imply a greater than b. Okay? So we will see when this is true. Okay? And for example, -4 squared is greater than -2 squared, right? But -4 is not going to be -2. Okay? So because -4 is smaller than -2. So this is true only when, okay? So here's there's assumption here. If a is greater than b, a is greater than b is positive, then a greater than b is equivalent to a square greater than b squared. Those two are equivalent. Okay, so you have to assume that's equivalence. Okay, so then back forward. Another thing is that, okay, if a is greater than b, then those two is also equivalent. This is k must be positive. Otherwise, you have to change the direction of the inequality. So those two important factors when you solve the inequalities, you have to be very careful. Okay. Okay. So square of x greater than x, and from here you will see that. Okay. Simple observation. X cannot be 0, right? Yeah, because otherwise 0 equals 0. second equation, x must be positive because otherwise square of x is not defined. Okay, so x is positive. If x is positive, I can square it. You see, using the above formula. Okay, so then you can square it. Okay, then you get x squared and x squared. Okay. So from here, another equation we can do is, since x is positive, so you can divide by x both sides. Otherwise, you cannot do it. You divide the x, this is positive. So it does not change the inequality. You know, multiply by k, divide by k is the same. Those two are equivalent. So you get 1 less than x. Okay, so x greater than 0, x is less than 1. Combine them together. X is between 0 and 1. So that is the answer. Of course, you know, a quarter is a possible solution. Okay, but that's not the only solution. You know, you have all the numbers between 0 and 1 is going to be the solution. Okay. Yeah, this is a pretty tricky problem. Okay, this is a pretty tricky problem. So let's look at the next one. Okay. Our next problem is a system of linear equations. Okay, we want to find the value of k for which these two equations will not have a common solution. Right? So what are the two equations? 6x plus 4y equals 7. Kx plus 8y equals 7. Right? Right, please work out this problem. Right, are you able to solve that? Anyone have answers? So that's based on the understanding on the linear equation. What does it mean? Now, if you don't understand the meaning of the equation, a linear equation, this means okay, geometrically. Okay, so that means you have two equations that if that means that if each equation represents a line, then those two lines must be parallel. Okay. Yeah, so that's a couple ways to do. Okay, each equation, you know, if you have an equation right in the form like that, so that means m is a slope. Okay, m is a slope. Okay, so m should be the slope. Okay, so so the first equation gives you negative 6 over 4x plus 7 over 4, right? The second equation gives you negative k over 8x plus 7 over 8. Okay. Now those are the two equations. The first one has a negative slope, but here's a 7 over 4. Both equations, another number is like 7 over 8. So those two lines passing through those two equations. Now, if they are parallel, then have no solution. So as long as they don't have they have the same slope, then those two lines has no intersection point. That means no solution. If the two lines have an intersection point, they have a solution. So you can use a geometric picture. You can say that negative k over 8 should be equal to negative 6 over 4. So that means k is going to be 12. Okay, when k equals 12 and those two lines are parallel to each other, there's no solution. But this is a geometric method, okay? So geometric method. Now, algebra method is just as you started to solve it, okay? You started to solve it, and you plug into the first equation, second equation, by the first equation. Yeah, that's called algebraic method. Okay, by the first equation, y equals negative 3 over 2x plus 7 over 4. Then you plug into the second equation, and then you will get kx plus 8, negative 3 over 2x plus 7 over 4 equals, right, equals 7. Okay, so you simplify this equation, you will get kx and minus 12x plus 14 equals 7. So you will get k minus 12x equals negative 7. And then if you're able to solve for this equation, then you have a solution. Okay, and then you get a y, but right? So that means this one has no solution when k equals 12. So this is another way you can get, okay? And when it has no solution, then k equals 12, okay? So that means, yeah, no common solutions means, yeah, that's, but let's do one more problem, and we are going to end the class, okay? If x and y satisfy the equation 888x 889y equals 890. Yeah, 889, okay? And 891x 892y equals 893. Wow, right? Find the, I just want to find the value of x minus y, okay? I'm not going to ask you to solve x and y, okay? You can find the, yeah, as long as you find the value x minus y, then you can find x and y, okay? So I want you to find x minus 1, not x plus 1. And yeah, very close. Yeah, Erica, you're doing great. Erica, you're doing great. Okay. Well, you just solve for x and y quickly. Okay, so Eric got x plus y quickly just because these two equations you use a subtraction. Okay, subtract equation 1 from equation 2, so you get x, then you get the y, and then you get let's see, 3x, 3y, and then 3. Okay, so quickly you can get x plus y. That's what I think Erica got. Okay, so when x equals x plus y, then you can use any of the equation. Okay, you can use any of the equation to solve the problem. Okay, you multiply the above. You can multiply by the above equation. You can use a substitution. You can multiply by 889 plus 889. Why? Because 889, that's called equation 3. And the reason I want to do that is I want to do the subtraction again. Okay, so equation 3 minus equation 1, for example. So you get x equals x equals 90, so it's x equals -1. So once you get x equals 1, then immediately y equals 1 minus -1, right? It's 2. Okay, so you get x and y. Okay, so there's always some tricks here to solve the system linear equations. So we solve several equations here. Okay, what I'm going to do is I'm going to send you today's lecture notes. Okay, and the plus cup of exercise, right, attached to the lecture note. Then also give you the set of previous math counts problem, and you try to do it by yourself, okay, within 1 week. How about this? Great. Okay, and I wish you to improve your algebra skill. We are going to go through all the formulas we need, our techniques, methods, okay, and through this course. I hope you can improve your math. Okay, so let's stop here.